In the next video, we're going to talk about sampling distribution of proportions property. Okay, so in here, if the sample size is large enough, we can apply the sampling distribution of p hat. So we have mu of p hat, which is this is the sample distribution of proportion, is the sample distribution's proportion, and this is the population proportion. Similar to the standard deviation, this is the sample deviation. P is the success rate, Q is the failure rate. So basically Q is equal to 1 minus P. N is the sample size. Okay, so for the central limit theorem is the independence, randomization, and the success and failure condition, which means you need to at least 10 success and 10 failures in your data. For example, suppose that 60% of the college students are either very satisfied or completely satisfied with their online shopping experience. You decided to take a national-wide random sample of 2,500 college students and ask if they agree. Is it reasonable to use the normal model for the sampling distribution of the sample proportion? Now, that means they basically ask you if this is satisfy the central limit theorem. So independence condition and the randomizer condition is always met. Now we need to check the success and failure condition. So M times P, how many students we try to survey? 2,500, and the proportion supposedly with 60%. So that means we times 0.6. This is equals to 150, which is greater than 10. So the success condition we met. You have at least 150 success. And now the failure. So I have 2,500 times 0.4 because Q is equal to 1 minus P. So 1,500, sorry, I calculated that wrong. This is equal to 1,000. So it's greater than 10. That means the success and failure condition is met. So that means the central limit theorem is met. That means we can apply this normal model for the sampling distribution of the sample proportion. Yes, we can use the normal model for the sample proportion. Find the mean and standard deviation of the proportion of a survey respondent who agree. Well, by the property, we know that the sample proportion mean, mu p hat, is equals to the proportion, which is equals to 60%. And the sigma for the sampling distribution proportion is equal to square root of success rate times the failure rate divided by square root of the sample size. In this case, it's 0.6 times 0.4 divided by 2,500, which is equal to 0.0098. So that means our sample proportion follow a normal distribution with a mean of 0.6 and sigma is 0.0098. Okay, what is the probability that the sample proportion of 2,500 college students who agree at least 57%? Well, we can make some prediction before we use a normal distribution. So we know that the center, the normal distribution, the center is going to be 0.6, and for each standard deviation you add in 0.0098. basically you add in 0.1. This I can approximate it to 0.01. So this is 0.61, this is 0.62. For the third standard deviation is going to be 0.63. And by the empirical rule, we know that 99% of data is going to be within 3 standard deviation. And look, we say at least 57% of the data. That means it's going to be everywhere above the 3 standard deviations. That means it's going to be almost 100%. Now, let's take a look and check. Okay, so the proportion mean is going to be 0.6, and the sigma is going to be square root of 0.6 times 0.4 divided by 2,500. Okay, and we want to know what if at least 57% of the college student agree. So it's going to be 99.89%. So that means in here we have the probability that the p hat greater than or equal to 57% is approximately 99.89%. Okay, so that's the probability of sampling distribution of proportion. Remember that we have the mu is equal to p hat, sigma equal to square root of p hat, q hat divided by n, the sample size, and there is a success and failure conditions. Okay, I'll see you in next video.